In this video, I'm going to walk through how to use the flamegraph profiler to actually see the r3bl-open-core TUI examples in action. So to get started, the first thing we should do is in the grab the r3bl-open-core repo from here. Let's see. And then once you clone it, then in this case I've cloned it into this directory. There's actually a subdirectory in here called TUI, which is what we're going to be working in. And here there's actually a new shell script which has a whole host of commands inside of it that we're going to use. The one that is of interest, let me make this font bigger. The one that's of interest for this session is actually run with flamegraph profiling. I'm also going to show how to run the log actually in this case. Oh, and I just noticed that's missing. That should be here in the main. Let's see. There should be a. Actually, there is a command for log. It's just not listed in the main entry. So here we can say log, yep, and then there's a print help. Let's see, print help, and then this one should also have log in it. And let's do this log. So I can, that was just me updating the new shell script so that when you just run it without any commands, it can show that there's such a thing called log. So this is roughly what this looks like. We can say log, and you can see the log output. And then here, when I say also in the TUI subdirectory, when I just say run.new and then run, and I run some samples that are in the repo, you can see that as I'm interacting with this application, the log is actually being updated. So that's roughly what's going on here. And the reason I showed the logger is because we're going to be using the flamegraph profiler to see what performance is with logging and without logging. So let's actually see what the current state is in terms of logging. So here in the TUI code base, there's actually a let me see. There's actually a oh, this is not the right folder. Let's see. In the TUI code base, this is the r3bl TUI crate. This repo contains a bunch of different crates. The r3bl_TUI crate is actually just one of them. So here, this is the one that we were working with for this particular session. So here we can see that let's see. Basically, the text user interface engine it allows people to create really cool. They're not graphical user interface applications, but they kind of have the feel of a graphical user interface application, but they all run inside of a terminal, so you can safely run this over SSH. So one of the things that we have out of the box is a markdown editor. And this markdown editor actually has syntax highlighting support and also parsing support, and it's actually built using a let's see, it's actually built using our own custom parser written in nom. So this is actually essentially in this markdown editor. When this document is actually loaded and rendered, this is actually, there's two phases to actually display to the screen. The markdown text, which is just plain text, has to be parsed as Markdown using this nom parser, and then it has to be syntax highlighted. And what that means is that the nom parser essentially generates an abstract syntax tree, and that abstract syntax tree gets basically analyzed, and then all the different elements in that abstract syntax tree get formatted. Like, for example, headings get this really cool gradient effect, and depending on the heading level, you get a different different kind of effect. So these are all happening because of the custom syntax highlighting and also the custom Markdown parser, because we actually changed the behavior of the Markdown parser so that it supports something called smart lists, which is, notice this indentation inside of these lists. They're handled a little bit differently than standard Markdown. So these are some of the benefits we get from having our own parser and our own syntax highlighting. So that is the code we're going to be profiling in this particular session. So the first thing I'm going to do is check what is the status of this profiling code with, let's see. So here there's some flags essentially in this mod.rs file in the TUI repo, sorry, the TUI crate, the TUI folder, the rebel TUI crate, where depending on what the values that are set here, logging will be enabled or disabled. So right now logging is disabled. So what we can do is collect some stats on what the performance of this application is with logging disabled. So we just, let's see, we had just run.new run. So instead, this time we're going to say run with flamegraph profiling. So run.new run with flamegraph profiling. And what that does is it'll run the same exact program, only this time when we execute this program, essentially the flamegraph profiler is going to be instrumenting the code that's running, and then the behavior is pretty much the same. Like I can run the logger, I can run the program, I can do stuff, and as I'm doing stuff, the profiler is actually collecting telemetry. So when I exit it, you'll notice that it's saying that the flamegraph profiler, is doing a bunch of stuff, and it's gonna end up collecting all the telemetry data and generating an SVG file, which is going to be interactive. So there's a crate that we're using to actually do all of this, and you can actually see that in action here. So when you say, I think it's called build all, yeah, there it is, build full. Where is it? Let's see, build full, there it is. So I think it's install cargo tools. Let's see, where is it? Let's see, cargo tools. Oh, this is a bug. I will fix this as well. There's some refactoring that was done recently to move some of these scripts around. So maybe that's, I see. These are all they have to be installed at the top level. I was looking in the wrong place. So essentially, at the top level of the when you check out this repo, we're in the TUI subfolder, but at the top level, the root folder, there's actually something called cargo install, or install cargo tools. One of them is cargo install flamegraph, which actually goes and gets the flamegraph tool that we just used. Okay, so in the meantime, the SVG has been generated, and now we can actually open it in Google Chrome. So it's actually just dumped right there. And when we say Google Chrome flamegraph, this is actually what the flamegraph looks like, and this is for the code that was profiled, and this does not use logging. So what I'm going to do is, let me get rid of these. I'm going to enable logging, and oops, sorry, that's the wrong one. Let me enable logging. Okay, so these two flags end up enable logging, and I'll disable them later, but I am going to then run with flamegraph profiling, and what this should do is essentially do the same exact thing as before. Only this time the code that's being profiled has logging enabled. So it should be different. The performance characteristics should be different. So here, as I scroll up and down, I'm basically, as you can see, the log output is a little bit different because there's a whole lot more log output, if you noticed, than the last time. So this is one of the consequences of enabling all this logging, and we're going to see in the flame graph very soon what kind of an impact this has on performance. So let us quit this. And once, depending on how long you run this application, a whole bunch of data gets collected, and that has to be written out to disk, and then that has to be turned into an SVG, which we will be able to look at in just a moment. And while that is happening, I can just revert these back so they don't get accidentally committed. And I want to commit this, let's say update run.new. Okay, script add log command. Okay, so it's still actually, it takes a little bit of time to generate this flame graph SVG, so it's still going. Let's see. As soon as that's done, we'll be able to start analyzing the flame graph that was generated by it. So let's see. Actually, while that's writing, let's go look at the flame graph for the code. This is the code that was instrumented that does not have any logging, and oh, there we go. The one with logging is actually generated. So I'm just gonna do this Google Chrome flame graph. I should have probably renamed that to save that to a different file, but fortunately this is loaded in Chrome, so as long as we don't hit refresh on this tab, we're good. We're good. So as you can see, these graphs look very different in both the situation where logging is disabled and where logging is enabled. It looks like there's a, I mean, just vaguely, just without really thinking too much, it looks like, actually, let me put this in a different window so we can see it side by side. There we go. So we can kind of see there's a whole lot more stuff happening when logging is enabled compared to when logging is disabled, which is to be expected, kind of using our intuition. So when we look at the code with logging enabled, which is this thing, the way the flame graph works is that the function that gets called consumes the most CPU time ends up being the widest one. So we can see that the terminal window main event loop essentially consumes almost the full lifetime of the program. And then if we dig a little bit deeper, the editor component ends up taking up quite a bit of CPU, and inside of that, render engine takes most of it. But then when we kind of drill down, we see something interesting. We see syntax, try, parse, and highlight. So this has something to do with syntax highlighting. And when you click on this thing, the SVG actually can be resized, and then you can reset, and then so it's kind of nice. It's quite interactive, so you can actually drill down into what's happening. So here we can see that actually, let me make this a little bit bigger. There we go. Here we can see that try parse highlight is taking up quite a bit of CPU, and off that, parse markdown is taking up most of this CPU, and so that's interesting. When we look inside of parse markdown, when we dig a little bit deeper, you'll notice that one of the things, two of the functions that are, let me make this smaller. Actually, let me do this. Let me make this full screen and then make that wider so you can see it. Okay. So in the parse markdown function, almost all this CPU is going to the format function, which is part of the debug trait, and some, again, format, which is part of the debug trait. So you can kind of see how this method called, and this is the standard library, char has a method called escape debug ext, and that seems to be taking up quite a bit of CPU cycles, which is kind of interesting. So, and it turns out that these functions are a consequence of logging, because when I enable logging, in order before the log actually first of all, logging is quite heavy because it's logging to disk. But before it logs to disk, it was logging essentially formatted output, and all of this formatted output had to be generated. And when this output was generated, it ended up taking quite a bit of CPU cycles, which is what you can see in this flame graph. So it's kind of cool to reconcile, what's happening, or what you can kind of see in the flame graph with what actually happened in the logs, because these logs are not for free. There's some cost at runtime to generating all these logs. Kind of makes sense. So it's kind of cool that even the parser logic is being logged here. So it's quite expensive to do logging, and so for the release version, definitely disable logging. Otherwise, a lot of cycles are going to go into the logging. So let's do a contrast with the code that didn't have any logging. And here we can see that there's a main event loop, which this one has as well. And inside of that, you'll notice that parse and highlight is a much smaller slice of what's happening in the overall picture, like much smaller. Like contrast that to how much wider this is, right? So this kind of gives you a sense of like how much CPU. Here's try parse and highlight, and I think on this side, where is it? Parse markdown. Oh, here it is, parse markdown. So we're just this parse markdown, right? This thing, which is not much going on here. Over here, it's taking up like a huge chunk of the screen. So you can kind of tell just from the amount of visual real estate that's being consumed, like what's going on. So if we reset it, and if we reset that, so you can kind of get a sense of side by side, like there is render in surface here. Oops, no, I mean, where is it? Event loop. And then we have parse and highlight, and then equivalently here we have parse and highlight. There we go. So there's in the difference between these two is that this is no logging and this is with logging. And as you can see, with logging, there's a huge amount of overhead that gets added because of the debug trait, because it needs to take all of the structs that were being dumped into logging into the file logger, and then they had to be generated before they were written to file. So not only is writing to disk expensive relative to non-writing to disk, not writing to disk, but also generating the log messages that get written to disk are also quite expensive. So in a nutshell, that's a sort of a guide into how to use flame graphs and the value in sort of profiling. So when people have certain intuitions around what is fast and what is slow, it's typically a really good idea to just run it in the profiler to see what is actually happening and what is actually taking up CPU cycles, and not necessarily rely on our intuitions. So on that, I will wrap the stream. Thanks, and have a good day.